Hello and welcome. This presentation is meant for you to understand how to utilize the Honeycomb model in your projects to assess the project through a complex lens. This model conveys a complex adaptive system, as the complexity does increase over time, can change, does not organically evolve towards a successful end state, and will change at its own pace. We begin at the center of the comb, our first cell. This cell is the basis of your project. In my case, this is the health of native bee populations and how they can be improved through mosaic pollinator gardens. The next 6 cells we will introduce will be our impacts. These cells will be the foundation of our project, so it's important to define these early on. The cells I chose are impacts on food, health, economy, waste, energy, and society. After this, the cells will change into your research towards your project. We've given these impact cells each their own unique icon, as further down the road they will become useful to us. While it may seem like the next step is to outline more cells around our current impact cells, I would advise against this. This is because we are attempting to use a dynamic way of thinking when placing our research within the model. When we close off pathways, as we will see later, we are unable to see where our research is weak and where it is strong. This dynamic approach will better utilize our ability to critically think and piece together a more comprehensive honeycomb. Instead, try to create immediate pathways with the respective impacts. You can see here I placed my first cell, a cited notation of how important pollination contributes to food production. While this piece of research can connect to other impacts, such as economy from agriculture or energy used in that agriculture, it is crucial to food. My second cell, a notation of the luxury effect that many high-income neighborhoods directly correlates with impacts on society. An important note is that distance from the center of the honeycomb does not correlate with the distal factor as presented in other models. The cells being placed from here on out will be research, ideas, and possibilities. So what happens to the cells between cells? Well, these cells can be links between their respective impacts, in this case, society and food. Rather than trying to fill in those in-between cells to try to make a symmetrical honeycomb, try to continue on your pathways as shown by the blue arrow. This will help establish your strongest and weakest points. One problem that may arise is losing track of your interconnectedness. Take, for example, this cell that the blue arrow is pointing to. What if this cell is somehow connected to waste? How will we know it's connected? Well, we've already actually started that process for labeling by creating unique icons that can be placed within a cell to notate certain features of that cell. I urge you to create an infographic of features you would like to track. Keep in mind that you can use these for your own research as well, as shown by the abacus notating that I should search for a positive deviance within that piece of research. For this project, I would like to set targets and indicators for those targets, like the SDGs as provided by the UN. You can also use these icons to notate a simple model within that piece of research. For example, a triangle can indicate that an epidemiological model can be used to observe a specific communicable or non-communicable disease. As we shift our focus back to our model, you can see that I've labeled my cells with their respective icons, allowing us to connect pathways that would not be available had this been a simple model. Similarly, as our model becomes more developed, we can see where certain cells may connect in different pathways, conveying the interconnectedness of the honeycomb, or our project. Cells can be shown more than once, but I would advise you to be cautious with this, as replication can deteriorate the quality of the model. Here's a look at my completed model, with the blue arrow showing our starting cell. What is great about this model is because it is not uniform, I can better identify the areas that I should focus on more intensely. While near the completion of your project, you would want symmetry within the honeycomb, conveying an absolute understanding of the interconnectedness of your project in line with your research. The model now will allow us to see where our progress is with no bias. Our purple arrow shows us that our food pathway is well developed. The green arrow shows our unique icon of green cells, indicating that more research is needed within the impacts on health. The light blue arrows show gaps within our honeycomb. The dark blue arrow points to the underdeveloped energy pathway. Finally, the red arrow shows a possible contradiction to our argument, in this case, a moral dilemma of social justice. And that's it. While this example conveyed a more eco-health oriented complex model, its utilization fits within One Health or planetary health as well. For this presentation, I utilized Microsoft Whiteboard to create the model and will provide a link to it for a more in-depth view. Thank you and happy learning.